Welcome students. Today we are going to discuss the architecture of 8085 microprocessor. The microprocessor word itself suggests that the processor is in small size and it has tremendous capacity to process the data. The 8085 microprocessor has its own significance in the family of microprocessor. Whenever the basic principle of the microprocessor is to be understood, we have to look for the 8085 microprocessor. The name itself suggests that 8085 microprocessor has the word length of 8 bit. Now let us try to understand first of all what do we mean by the word length. In our day-to-day language, we use different day-to-day life, we use different languages like English, Marathi, Hindi, and so on. Each and every language comprises with its own alphabets. Like in case of English, we have 26 alphabets from A to Z. And the different words are generated by the different combination of these different alphabets. In the same manner, whenever we enter into the digital world, the digital world understands the language of binary only. In case of electronics and the digital electronics, that too we know that the binary language is comprises of only two digits, 0 and 1. So if we think that the all digital machines that can understood the language of digital electronics, that is the binary language, then they must have the capacity to understand the different words created or generated by different combinations of these zeros and ones. So when the different combination of these zeros and ones are generated, it work as the word for the microprocessor or in all totally any digital machine. And whenever we want to convey certain message to these digital machines, we have to write the words in the form of zeros and ones. Each and every digital machine has its own capacity to understand the set of such digital combination. Whenever we talk in terms of zeros and one, whenever 8 bits, each and every digit like 0 and 1 is considered to be a bit. And when 8 bits are comprising together, they are coming together, it forms a byte. 8 bits forms a byte and 4 bit forms a nibble. So if a microprocessor or digital machine is capable of handling 8 bits simultaneously, that is, it can perform the parallel operation of 8 bits, then we say that the microprocessor has the word length 8 bit. So in short, our microprocessor 8085 has the word length 8 bit. We want to understand, we want to know the basic architecture of this microprocessor. So as to understand this architecture of the microprocessor, let us have a brief look at the microprocessor 8085. It is 8-bit general purpose microprocessor. Let us try to understand each and every aspect of this 8085 microprocessor. The 8-bit general purpose microprocessor means, as I have told you, it can handle 8 bit of data simultaneously, or it can process 8 bit of data parallelly. It is capable of addressing 64 kilobytes of memory. That is very important. The address bus of microprocessor 8085 is of 16 bit, and therefore the number of memory location it can go, it can understand, or it can access is 2 raised to 16. So whenever we try to find out the number of memory location that can be accessed by a particular address bus. So if it is of 16 bit, then 2 raised to 16, and if you calculate this 2 raised to 16 number, it comes near out to be 64,000. It is actually 65,000 and something, but it is said that it is 64K memory. It can access 64 kilobytes of memory. The hardware of this 8085 microprocessor has 40 pins. So There are different input output terminals. We can interface the data, we can interface the memory locations with the help of these memory lines or the address buses, and there are some serial input data, serial out, number of pins are there. But in all totally we have 40 pins. So please remember, whenever hardware of this microprocessor is to be discussed, we have to mention that it has 40 pins and it comes in the DIP package, that is dual inline package. It requires plus 5 volt power supply. As of in case of any IC, it requires only plus 5 volt DC power supply. It can operate on the plus 5 volt power supply. It can operate with 3 megahertz clock frequency. This is an important concept. What do we mean by the clock, or what do we mean by the frequency of the clock? The microprocessor uses its own clock for the operation. Each and every process of the microprocessor is performed on a particular clock pulse, and that clock pulse works as the basic structure of its clock. So when an oscillator is connected between its two terminals X1 and X2, that is input terminals, and the frequency of the oscillator is 3 megahertz. You can find out the time period by simple mathematics, and if you can find out the time period, that time period or the time interval required by the microprocessor 8085 to perform a complete operation. So the speed of the microprocessor is of 3 megahertz frequency, and let us try to understand the overall structure of the microprocessor. This is the architecture of the microprocessor. See, whenever you want to understand behavior of the microprocessor, or how the data enters into the microprocessor, how it is accessed, how the memory is accessed, how the different input output data items or the data bits are accessed, and how they are processed inside the microprocessor, we must be able to know, we must be able to understand the internal structure of the microprocessor. This is the rough architecture of the microprocessor. There are different blocks in this architecture, and we are going to discuss each and every block in detail. Remember, microprocessor can process 8 bit of data, and all these are the buses. See, this is the bus, and this is the bus, and this is the bus. These are the address buses and data buses. These are the different control signals here. These are the control signals, and these are the different blocks. So we will try to understand, and we will try to discuss each and every block in detail. So let us try and start with the operation of 8085 microprocessor. A microprocessor can perform 4 different type of operations. It can read the memory. So memory is a different identity. It has 64 kilobyte of memory. A separate IC is there. So it can read the data stored in the memory. So that operation is called as the memory read operation. Whatever data generated as a result of processing inside the microprocessor can be stored in the memory location, that is called as the memory write operation. So microprocessor can read from the memory, and microprocessor can write into the memory. As the data flow maybe from memory to microprocessor or from microprocessor to memory, similarly, only memory is not connected with the microprocessor, or microprocessor is not obtaining the data only from the memory. At the same time, microprocessor is interacting with different input-output devices. And these input-output devices are generating the data and storing the data. So simultaneously, microprocessor has to interact with the input-output devices also. So microprocessor can read the data from the input device, and microprocessor can write the data into the output device. So these 4 major operations which microprocessor can perform. Whenever we discuss about the interaction or the exchange of data in between microprocessor and memory, and in between microprocessor and input-output devices. Let us begin with another aspect, the communication inside the microprocessor, or communication in between the microprocessor and the different input output devices as well as the memory. Remember, memory is accessed by the microprocessor by the address bus. This address bus is of 16-bit and therefore it can access 64,000 memory location. You can store, you can access 64-byte data with the help of 8085 microprocessor because it has 16-bit data or 16-bit address bus. It has data bus of 8-bit. So inside the microprocessor or in between the microprocessor and memory or microprocessor and the input output device, the data of 8-bit can be transferred, can be processed, can be stored and can be transmitted. And there are certain control buses are also there. Now, this is the rough structure of how microprocessor 8085 interacts with the different input output devices. See, this is the microprocessor 8085. This is the memory structure. It has 64 kilobyte of memory, that is 64,000 memory locations available inside this memory. These are the output devices connected. These are the input devices connected. Now remember, microprocessor 8085 is capable of interacting with all three types of devices: memory, output device and input device. And the interaction is in the form of data. So data can be had from the memory, data can be given to the memory. Similarly, the output devices can give the data and can give it to the microprocessor. The input devices can have the data from the microprocessor. But to have the interaction with the memory and the output and input devices, this address bus plays an important role. Remember, this address bus is connected to memory, address bus is connected to output device, and address bus is connected to input devices also. So whenever microprocessor has to interact with one of these three devices, memory, output device and input device, it has to use the address bus to specify, to locate which devices has to be used for the exchange of data. There are certain control signals generated for the operation or the smooth operation of exchange of data between microprocessor and memory. And these control bus or control signals, they are also connected with the microprocessor and the input output devices. See, the memory read operation, how it can be performed or how it is performed with the help of the microprocessor, we will see. Microprocessor places 16-bit address into the address bus. As I have told you, microprocessor has 16-bit address bus and it places 16-bit address onto the address bus through the program counter. Program counter generates or remembers the data, the address of the memory location, and it is stored, it is kept on the address bus. Decoding the address bus for identifying the memory address of the data, it decodes the address and identifies the memory location which it has to be addressed or which it has to be located for the exchange of data. Microprocessor send MEMR control signals enable the memory IC. So MEMR bar suggests the this particular signal is active low. MEM stands for memory and R stands for read. So whenever memory read operation is to be performed, the control signal goes low for the memory IC, and that IC is activated. Enabling means activating that IC, and that IC is activated, and the memory, the transfer of data from the memory to the microprocessor can be performed. Data of memory location is placed in data bus and microprocessor. The data bus is of 8-bit, and we know that the address bus is multiplexed. The lower byte of the address bus is used as lower byte of the address and as well as the data byte. So data is transferred into the microprocessor through this lower byte of the address bus. So this is how it can perform the transfer of data. So look here, it has generated the 16-bit address from A0 to A15. That address is generated by the microprocessor 8085. We keep this address on the address bus. This address bus will bring that address to the memory decoder. This memory decoder will decode that memory address, and the concerned memory location is activated, and the data from that memory location is kept on the data bus, and the data bus transfers the data into the microprocessor. So, and the important signal is MEM R bar, because unless and until this MEM R bar signal goes low, this particular IC cannot be activated. So first of all, this MEM R bar signal goes low, then address is transferred to the memory decoder, then memory decoder point out that memory location, that memory location is O point, and that memory, the content of the memory location or the data from that memory location is transferred to the microprocessor. It is very interesting phenomenon of the transferring of the data. Now, when the data is available, we have inside the microprocessor the 8-bit signal, 8-bit data is coming from the memory. It is kept on the internal data bus. This internal data bus is connected to the ALU section. It is bidirectionally connected to the internal ALU section. ALU stands for arithmetic logic unit. There are different parts of the arithmetic and logic unit that we will see in detail. The instruction decoder is also connected to the internal data bus bidirectionally. There are six scratch pad register, we can call it B, C, D, E, and HL. So this structure of the scratch pad register is also connected bidirectionally to the 8-bit internal data bus. Now, data flow from memory to microprocessor, how it forms, how the data flows from memory to the microprocessor. The 16-bit memory address is stored into the program counter. We know the program counter is an important block of the microprocessor which contains the address of the memory location from where the next instruction or the next byte of data is to be transferred into the microprocessor. So program counter plays the role of storing the address of the memory location. The program counter sends the 16-bit address on the address bus that we have seen. Memory address decoder decodes, and that also we have seen, and we will go at the next slide. The control unit sends the control signal RD bar in the next clock cycle, and memory IC is enabled. We have know that unless and until the read bar signal goes low, the IC cannot be activated. And when the memory IC is enabled, the byte from the memory location is placed on the data bus, and after that data is transferred into microprocessor, and that too onto the data bus of the microprocessor. And this, as we have seen in the last slide, the internal 8-bit internal data bus is connected to the arithmetic and logic unit. The arithmetic and logic bidirectionally, it is connected bidirectionally. The bidirectionally connected arithmetic and logic unit consists of accumulator, temporary register, flag register, and arithmetic and logic unit. Remember, the arithmetic and logic unit consists of accumulator, 8-bit register A, temporary register of 8-bit, flag register of 8-bit, though there are only 5 flags active 5 flags are available in the 8085 microprocessor, and the actual the arithmetic and logic unit where the processing of the data, either arithmetic processing or logical processing, is to be performed. Then we have seen this thing. This is the arithmetic and logic unit. Actually, this is the arithmetic and logic unit, and it is connected with these different blocks. We have seen accumulator, temporary register, and flag register. And the internal data, which is coming from the the memory, can be had by the accumulator, can be temporary register or flag register, and it can be processed by the arithmetic and logic unit. Now, how the data is processed? The temporary register is not accessible by the user. That is very important thing. You cannot store directly into the temporary register, or you cannot use the temporary register. So user cannot have the access to the temporary register. So it cannot be read by the user. The ALU always operate with 1 or 2 operand. The ALU always it can operate 1 or 2 byte of data. So whenever arithmetic or logical operation is to be performed, either addition, subtraction, adding, ORing, etc., we need 2 bytes of data. So one of the byte is always present in the accumulator. So accumulator is a default register for the ALU. It takes 1 byte of data from the accumulator, and another byte of data can be had from all of the 6 scratch pad register, but they are not directly accessible by the ALU. The data from those BCDE HL6 scratch pad register is first transferred into temporary register, and the temporary register is accessible by the ALU. So 1 byte is taken from the accumulator and another byte from the temporary register, and then it is processed. The final result So whatever operation is performed by the arithmetic and logic unit, either addition, subtraction, multiplication, ANDing, ORing, and so on. So the result of this arithmetic and logical operation is again given to the accumulator. So accumulator stores the result of the operation. The sequence of operation is an important thing. One operand in the A register that I have told you. The other operand may be in the general purpose register or memory location, which will be transferred to the temporal register that I have discussed. Therefore, we will go to the next slide and let us have the next slide. The different operation which microprocessor can perform is addition, subtraction, logical ANDing, logical ORing, logical XOR, complement, increment, decrement, rotate left and rotate right, and clear. So these are the different operations microprocessors arithmetic and logical unit can perform. The timing and control unit, it is an important block of the microprocessor, timing and control unit. So we will discuss this timing and control unit in our next lecture. So I will revise what I have discussed with you up till now. That microprocessor 8085 is of 8-bit microprocessor. Remember, it can handle or it can process 8-bit data parallelly. It has general purpose microprocessor. It is general purpose 8-bit microprocessor. It has memory capacity of 64,000 memory location. It is 40-pin IC. It requires 5-volt power supply and it operates on 3 megahertz clock pulse. This is the architecture of the micro. Remember, this architecture you have to draw at the time of whenever you have to explain the architecture of the microprocessor. These are the different memory read, memory write, input, output, read, input, output, write operations which a microprocessor can perform. There are 3 different buses: address bus of 16-bit, data bus of 8-bit, and control bus or the control signals, different control signal. This is how the microprocessor connected with the memory output and input devices, and how microprocessor extract the data from the memory that we have seen. How the MEM R bar signal is important. It can activate the memory IC and data can flow from memory to the microprocessor. Once the data is available inside the microprocessor, it can be performed or it can be processed with the help of arithmetic and logic unit, which comprises of accumulator, temporary register, flag register, arithmetic and logic unit. How it is connected, that is shown into this slide, and how the data is processed, and the sequence of operation and different operations. And we came up to the timing and control unit, but we will stop here and we will discuss this timing and control unit in our next lecture. Thanks for listening me, and be in tune. I will be explaining all other aspects of the microprocessor and interfacing of the microprocessor in the due course. Thank you very much.